Hello students, welcome to this lecture on organic chemistry regarding the nucleophilicity. This is a very important topic in organic chemistry when you are going to understand the organic chemistry, that is the reaction of the organic chemistry, and that is going to be very crucial for you to understand it. So this is K.K. Mukherjee in the Science with Mukherjee Sir YouTube channel. Today we are going to discuss the nucleophilicity. We know already what is nucleophiles. If you do not know, I will tell you what is nucleophiles. Nucleophiles is basically a Lewis base which can able to donate the electron pairs to the other atoms. As we are talking about the organic chemistry, reaction in the organic chemistry, so other atom is the carbon atom. So this is a reaction between the electrophile carbon atom with the nucleophiles, and nucleophiles is basically the Lewis base which can donate the electron pair. So we can write the nucleophiles. What is nucleophiles? Nucleophiles is basically the Lewis base capable of donating electron, electron pair to any atom. Electron pair to any atoms. So atom in this case, that will be your carbon atom. So what is the nucleophilicity? Nucleophilicity is basically how easily a nucleophile can donate its electron pair to the other atom is a qualitative terms of the nucleophilicity. So nucleophilicity is basically, you can say, the capability of the nucleophiles to donate the electron pairs. So what is nucleophilicity? Phile donate electrons pair. So nucleophilicity is basically how easily a nucleophile donate the electron pair to a electrophile. In this case, this is carbon atom. Carbon atom acts as a electrophile here. Okay. But how do we measure the nucleophilicity? This is the question. The nucleophilicity can be measured. Nucleophilicity can be measured by the rate of the reaction. If it able to donate electron very easily, naturally the rate of electron will be higher, then we will say that it is have the good nucleophilicity. So question arises, what are those factors by which the nucleophilicity depend? What are those factors? Now we are going to understand those factors. First one factor, that is the factors of nucleophilicity. There are basically 4-5 factors that we are going to discuss in this video. Number 1 factor, that is the negative charge. Negative charge on the nucleophile. Negative charge on the nucleophile. Negative charge. Second factor, that is the electronegativity. Okay. Third factor, that is polarizability. Fourth factor, the solvent. Fifth factor is steric hydrants. So these are the five factors that is going to influence the nucleophilicity. That is the negative charge on the nucleophile and electronegativity, polarizability, solvent and steric hydrants. So this will gradually you understand with examples so that you can able to understand what is basically all those factors going to influence the nucleophilicity. Okay. This is the first factor is negative charge. It is a very simple rule. Higher the negative charge, higher the negative charge is equal to higher the nucleophilicity. Higher the negative charge means higher the nucleophilicity. As for example, that is OH minus ion, that is a nucleophile. Its nucleophilicity is more than H2O. NH2 minus ion, its nucleophilicity more than NH3. Acetate ion, CH3, C11O, O minus. Acetate ion is more nucleophile, is a good nucleophile than a acetic acid. So you can see here what is happening, the negative charge is there. Here is negative charge is here is negative charge, and here also you can see the negative charge that is going to influence the nucleophilicity of this nucleophile. So OH minus is greater than H2O, NH2 minus greater than NH3, and the acetate ion is greater than this acetic acid. So these are basically what? This is the conjugate base. Conjugate base is always a good nucleophile than its counter conjugate acid. So that is the things. Second point is electronegativity. Electronegativity of the atom has an inverse relationship with this nucleophilicity. That is, you can say inverse relationship. Inverse relationship means higher the nucleophilicity means that it will have the lower electronegativity. Inverse relation means higher nucleophilicity means higher electronegativity means lower electronegativity. Lower the electronegativity, higher will be its electrophilicity. Higher will be its nucleophilicity. Why it is so? Because when there is a lesser electronegativity, that atom, the electron in the atom will be loosely being held. As because of the lesser electronegativity, it will not attract this electron pair very firmly, so it can easily donate. That you can see here, NH3 is good having the higher nucleophilicity than H2O, and H2 is higher nucleophilicity than HF. So you can see here as we go left hand side to right hand side of the periodic table, what we will find, that electronegativity goes on decreasing. Electronegativity goes on decreasing. So electronucleophilicity is a reverse relation, means it will goes on increasing. You can see N has a lower electronegativity than your oxygen, and oxygen has a lower electron than fluid. So you can see how it is been moving. That is NH3 is electrophile. This is the electrophile, and the higher electrophilicity, this is the nucleophile. Sorry. NH3 is the nucleophile. It is having the higher nucleophilicity than H2. H2O has the higher nucleophilicity than the HF. So this is how it moves. Now the third point, that's a very important thing, that is polarizability. Polarizability. That you need to understand what it means. Polarizability means that electron cloud can be easily polarized. Electron cloud on the atom will be easily polarized, and that will only happen when, suppose this is one atom and this is another atom. So electron cloud here will be less polarized by other atoms, but in this case, as because of its higher radius, its electron cloud will be polarized. So naturally, when there is a high polarizability of the atoms, this type of atom, when it is in the nucleophile, it will going to increase the nucleophilicity. That is, we can observe as we go down the groove, the diameter, radius of the atom goes on increases, and its polarizability also goes on increases. Means it can be, the electron cloud can be easily polarized because of the fact the electron is further away from the nucleus. Here this is near to the nucleus, so it can be easily polarized. The electron density can be easily transferred to the other atom, so it will be a good nucleophile. Its nucleophilicity will be higher, that we can observe as, for example, H2AC is H2S and that is your H2O. This oxygen, sulfur and AC in the same group, and you can see as we go down the level that the diameter, the radius of this atom goes on increasing, and their polarizability goes on increasing. That is why it is having the higher nucleophilicity than this H2S. H2AC, the higher nucleophilicity than H2S. H2S of the higher nucleophilicity from the H2O, and that is due to the polarizability. Now we are going to discuss another two reasons. Fourth number point, that is a solvent. Solvent also going to influence the nucleophilicity. How? We know there are two types of solvent. One is protic solvent. Protic solvent, that is H2 alcohol. These are all the protic solvent, and they can easily able to form the bond, hydrogen bond with the other molecules or the ions. So when we compare the nucleophilicity of these I minus, that is iodine ion, will be a higher nucleophilicity than the bromine ion. Bromine ion has a higher nucleophilicity than the chlorine atom. Chlorine ion and chlorine ion is the higher than the fluorine ion. So we can see that in the protic solvent, this is the trend of the nucleophilicity. Whereas in case of aprotic solvent, aprotic solvent means here in this case, this type of solvent, this solvent, as for example, dimethyl formamide, acetonitrile, all are the aprotic solvent. And this aprotic solvent, this trend will be reversed. This trend will be if so this trend will be reversed in the aprotic solvent. Okay. Now how? That is how the solvent is also going to influence the nucleophilicity. And fourth point, that is a very important thing, that is steric hydrants. Steric hydrants. Steric hydrants means that when the nucleophile has a bulky group, it will not serve as a good nucleophile. So its nucleophilicity will be affected by this bulky group. How it is so? You can see this example. This is a good high, this nucleophilicity is higher than this. Its nucleophilicity is higher than this because there is a branching, there is a branch here. Now this nucleophilicity further, that is, we can see less than this. This is a carbon atom, and here again this nucleophilicity will so you can see there is a bulky group. Here is no bulky group. Then its nucleophilicity much more higher than of those things. So you can see here. Okay. So the steric hydrants is another factor that is going to influence the nucleophilicity of the nucleophile. So that is all for this factor. What are the factors? 5 factors. First factor, the negative charge. Second factor, the electronegativity. Third factor, the polarizability. Fourth factor, that is solvent. And fifth factor, that is steric hydrants. So these are 4 factors going to influence the nucleophilicity. And we are going to take some questions that will again clarify your doubts. Okay? Now some 3-4 questions will solve, and after that we will go to the end to this video. Until then, watch this video. This is the first question that you can see. In this question, it has been told that which of the following nucleophile is the most nucleophilic but least basic. In this case, you have to remember one thing, that electronegativity. Electronegativity, it will be the deciding factor here, and you know, as we go down the group, the electronegativity goes on decreasing, and so what is going to happen? The nucleophilicity will going to increases. So in this case, Ib minus will be the most nucleophilic. Its nucleophilicity will be higher. But it is the least basic. Okay, the answer to this question is I minus. The next question, the order of decreasing nucleophilicity means you have to find out which having the highest nucleophilicity, then the order will goes on decreasing, and the last nucleophile will be the least. So you can see one thing, when there is a charge on the nucleophile, higher negative charge means higher nucleophilicity. So in this case, H2 will be the least nucleophile. Okay. Now we have to see from this angle, from these 3, they are basically charged, and which is having the highest nucleophilicity. You can see here that CH3 has a plus I effect, plus I inductive effect. So it can easily donate the electron. So what is going to happen? This charge, negative charge, there is an electron on the oxygen in the CH3O methoxy group. In this case, it will be easily be released. So among these nucleophiles, CH3O minus will be the highest. Then you can see here there is due to the hybridization, due to resonance, CH3 pseudo minus acetate ions, this minus charge will be delocalized, so it will not easily available for donating. So this will be the less than, nucleophilicity will be less than this OH minus ion. So this will be the right answer, where you can see CH3O OH minus is. Okay, so that is the case. So in this way you have to answer these questions. Okay, this is the question number 3. The decreasing order of nucleophilicity among the nucleophile. In this case, you can see for this and for this structure is very stabilized structure. It is more stabilized than this acetate ions because of the resonance. Because of the resonance and lot of hybrid structure it can form, and this also can form. So this O minus, this negative charge, the electron donating capability of this species, that is a paratoluene sulfonate ion, and here the acetate ion will be less than this. And among these two, the Cl minus will have the highest nucleophilicity because of the electronegativity of the nitrogen. So what will be the order? You can see order of the Cl minus will be the highest nucleophilicity, followed by CH3O minus, and that will be followed by the acetate ions CH3, CO minus, and that is again this CH3C. This is the right answers. So you can understand here due to the resonance, this electron, this negative charge is delocalized. So that is why it will not able to donate the electron much more readily compared to this. And here the two factors, that is the electronegativity of the nitrogen and oxygen, comes into play, and this gives the weightage of the Cl minus ion, and it is having the higher nucleophilicity. So that is all for today's video. Hope you understand what I want to say to you, and you are much more clarity about the subject. If you do not have any problem, you can give your comments in the comment section, and if you like this video, you can share with your friends. Thank you very much for listening, and all the best.